In this video, we are going to look at calculations where we are given a specific amount of energy released and are asked to determine the mass or volume of fuel required. If you look at the flowchart, you notice that these questions always start with a known value of energy. Our first step is to work backwards to find the number of moles of fuel that must have undergone combustion. To do this, we arrange the formula delta H is equal to Q over N to calculate moles, which gives us N is equal to Q or energy over delta H. Once we know how many moles of fuel that has reacted, we do not need to use mole ratios because the enthalpy change already refers to 1 mole of fuel itself. From here, what we do next depends on what the question is asking. If we want to find the mass of fuel, we multiply the number of moles by its molar mass. If the fuel is a gas, we can then find the volume using the formula V is equal to N times the molar volume, which is 24.8. If the fuel is a liquid, we first must find the mass, then convert to volume using density. Let's go through an example together. In this question, we are asked to determine the volume of methane measured at standard laboratory conditions that must burn completely to release 4.00 times 10 to the power 4 kilojoules. We are also given the balanced chemical equation for methane along with its molar heat of combustion. Step 1. What we need to do first is to convert energy to moles of methane. We do this by rearranging the molar heat of combustion formula. So moles can be found by doing Q divided by the delta H. So if I do this, I'm going to get an answer of 44.94 moles. As this reaction is conducted under standard laboratory conditions, we can then calculate the volume by doing V is equal to N times Vm, giving me a final answer of 1.11 times 10 to the power 3 liters.